square roots. Today's the 11th. So yesterday we looked at just square roots of numbers. Today we're looking at square roots of monomials because monomials are numbers or variables or combinations of numbers and variables. So yesterday we just looked at the number side of things. Today we're going to look at the variable side of things and the numbers and variables side of things. So square roots with variables is the main idea that we're dealing with today. That would be kind of the monomial square root idea. And it says square roots with variables are also known as monomial square roots. Just like numbers, variables can also be simplified. So they simplify in a slightly different way because squaring a variable is a little bit different than squaring a regular number. So if m is a multiple of 2, and if you look down here, m is the exponent. So under the square root, if you have a variable that's raised to an exponent, if that exponent is a multiple of 2, you're going to use this rule right here. You're going to say the square root of a to the m is equal to just regular a to the m divided by 2. And I'll explain what that means in just a moment. If your exponent is not a multiple of 2, you're going to break it apart. So something either is divisible by 2 or it's not divisible by 2, right? If it is divisible by 2, you just divide it by 2 and you get a new exponent. If it's not divisible by 2, you will always have 1 left over. For example, if you look at problem number 1, the square root of x squared, what multiplies by itself to equal x squared? What times what equals x squared? X times itself, which would be x times x. So the square root of x squared, ready for this? It's x. If you undo something being squared, all you end up with is that thing. For example, let me just use some numbers real quick here, like we saw yesterday. So if I were to say the square root of 4, you would say, what? 2. Now, if I were to write 4 as a number with an exponent, would we all agree that 2 squared is the same thing as 4? What does 2 squared equal? 4. So those two things are actually the same, right? And if you square root something, the squared ends up basically canceling out. So this is still equal to 2. If we were to do the same thing, let's say 25, square root of 25, what does that equal? 5. If we used, instead of 25, if we said 5 squared is the same number as 25. And if you square root something that's being squared, you just end up with the number. So essentially, you're getting rid of the square. When the square and the square root kind of cancel each other out, and you end up with whatever that base value is. Here's the same thing. X squared is just x times x. So if you undo something being squared, all you end up with is that answer. Now, what we're talking about up here is that we're essentially taking that exponent and we're dividing it by 2. So technically speaking, here's what's going on. I'm going to show you the work just to show you why this works, and then we'll do this maybe one more time with number 2. And then we'll just kind of move on to the mixtures of numbers and variables. So with problem number 1, if you were to follow what it says up here, use this rule here. So you were saying a to the whatever the exponent is divided by 2. Well, the exponent here is 2. So we would have x to the 2 divided by 2. What's 2 divided by 2? 1. So that would equal x to the first power. Well, x to the first power is just x. So if you square root x squared, once again, you end up with x. Let's try this next one. M to the power of 6. Is 6 a multiple of 2, or is 6 divisible by 2? Yeah. So we would have m to the 6 divided by 2 power. What's 6 divided by 2? 3. So we get m to the power of 3. So basically, we're reducing the exponent by half. That's essentially what's happening. If it's an even number, we reduce it by half. If it's an odd number, once we get to number 7, I'll show you what to do with that. But if your variable has an exponent that is an even number, just cut that even number in half, and then write your answer without the square root. So on number 3, we are going to square root both the number and the variable.
Are you just going to cut k in half so it would just be like an upside down B?
So what is the square root of 9, first of all? What was it? Square root of 9, what multiplies by itself to equal 9? Other way around.
Oh,
3, yeah. So 3, and then cut the exponent in half. We get k to the first power, just k, so the answer is 3k. Square root the number, divide the exponents in 2. If they are divisible by 2. When they're not divisible by 2, we will talk about that. Number 4. Any thoughts? 8. Yep, 64 square rooted would be 8. By the way, you're welcome to continue to use your calculator to square root the numbers. But you cannot type in the variables into your calculator. So you can still square root the numbers with your calculator. And then what are we going to end up with exponent wise on p? Yeah, divide the exponent in half, so 8p squared. I'm going to go to the board here. Actually, you know what? I'm just going to go ahead and show this off to the side. So if we were to have, let's just think about it this way. If we're going the opposite direction, so if we start with the answer and we try to get back to here, think about this for a second. If you have 8p squared times 8p squared, you would use the product rule, right? You'd multiply your regular numbers, 8 times 8, and you get 64. And if you use the product rule, that means you are adding the exponents together with the same variables. So 2 plus 2 would be to the 4th power. And so if we multiply those back out, we end up right back where we started. So 8p squared times 8p squared is 64p to the 4th. That's what we started with. If you square root it, you get our answer right here of 8p squared. All right, we've got 2 more that are like completely perfect squares. Then after that, it's going to get a little different. So number 5. Any thoughts on that one? What's the square root of 100? 10. And then what's after that? xy. Yeah. So the exponents go from 2 to 1 because you're cutting them in half, but if it's an exponent of 1, you don't need to write it. So 10xy for number 5. Number 6, what's the square root of 49? All right. And then what's after that? So let's get an a in there too. So a, and then b to the 3rd, c squared. Good. So we're just cutting in half the exponents with the variables, and then we're square rooting the regular number. Now, for number 7, this one's a little different. Is 5 divisible by 2? No, it's not. So what this says up here, and it looks kind of complicated the way it's written, but it's really not a complicated process. So you're going to break it apart. You're basically going to take the exponent that's there already, 5. You're going to subtract 1 from it to make what? What's 5 minus 1? 4. Okay. So this is equal to the square root of y to the 4th, because that would be 5 minus 1, times 1 more of that same variable, which would just be y, so times y. So this would be the square root of y to the 4th power times y. Yeah. All right. You got a job for him?
Oh, I got a job for him.
Oh, that's excellent. Okay. Oh. So, y to the 4th power. By the way, we can break these apart immediately if we want to. We could say y to the 4th power, square root of y to the 4th power times y. Just breaking it apart using multiplication. What would this first one turn into? Now that we have an even number, it is divisible by 2. It's y squared, exactly. So we get y squared, but this one can't simplify, so it stays under the square root. Kind of like when we had our regular numbers yesterday, where there was still a number underneath the square root. Same thing happens with variables sometimes. So we end up with y squared times the square root of y, or y squared root y. What did you do? I don't believe that. All right. So let's have a look at number 8. So this first variable here, a squared, that one's divisible by 2, right? So that'll just be a. So we can write a. And then b to the third power, not divisible by 2. Actually, you know what? I'm going to write it out like this. I'm going to say square root of a squared, because we can break apart every single piece of this, times the square root of b squared times the square root of b. So the square root of a squared doesn't change. However, b to the third power needs to be broken into something that is divisible by 2 with the exponent and something that isn't. The thing that you need to know about when we're dealing with variables and exponents here is that this final variable will always just be the variable by itself. Because when you talk about things that are divisible by 2, even numbers are divisible by 2, odd numbers are not, but odd numbers can be made into even numbers by taking away 1. So that means there's always only going to be one extra of a variable. You'll never have an exponent with the leftover variable. Because whatever over here is going to be an even number, so there should only ever be one leftover value of that variable. Does that make sense? Like this will always just be the variable by itself, because this one will always be divisible by 2 when you break it apart. So a squared square roots to a, b squared square roots to b, and we still have the square root of b after that. So we get ab root b. AB root b, yeah. Try number 9. Try number 9 on your own. See what you end up with there. You can write it, separate it out like that if you want to. If you can figure it out just by taking a look at it, that's fine too. The one thing you need to know though is that this will not work if you type it into a calculator. Your calculator will not do this for you. So this is a process that you need to learn how to do.
The ones that have exponents be on the inside of the square root or the outside.
Say that one more time.
So if we make the y to the second power, would that be inside or outside?
Initially, it will be underneath. Kind of like right here. This b squared was underneath, but then it's square rooted to regular b. So, for example, on this one, I'm going to write x squared. I'm just going to separate these all out. Times, let's see, y to the third power needs to be broken apart. So that'll be y squared, square root of y squared times the square root of y, because we got to break that apart. And then we're going to have the square root of z to the fourth. That one does not need to be broken apart because it's an even number, which means you can divide it by 2. So are there any questions why I'm writing it like this? Okay, I don't see any hands up. And something you can do next is you can change the order of things too, because we're going to have to change the order when we write our answer. So I'm actually going to swap these two, because the square root that can't be square rooted, the thing that has to stay a square root, will always end up at the end of the problem. So technically we could do this. X squared, square root of x squared times the square root of y squared times the square root of z to the fourth power times the square root of y. Now I'm showing a lot more work than what you will generally do, but I'm just kind of showing you step by step why this works. The first 3 of these all square root perfectly. Square root of x squared is x. The square root of y squared is y. The square root of z to the fourth is z squared. And then the square root of y needs to remain under the square root. So we get x, y, z squared times the square root of y. Any questions about that one? Now, once you start to get pretty good at this, you'll be able to look at a problem like number 10, and you'll be able to just say, all right, the answer is 12k root k. That's the answer. Now, I'm going to show you the in-between step here, but the more you work with these, the more you'll be able to kind of separate things out just using mental math. But because, let's see, 144, square root of that is 12, right? So we're good with that. So we got 12, and then we're going to say times the square root of k squared times the square root of k. Because we have to split apart the k to the third into k squared and k. And when we square root this, it no longer has the exponent of 2. It just turns into regular k. Yeah. So this is that in-between step that we can use to get from the first to the last. So we're still square rooting our regular numbers as we normally would. And then anything that's an odd exponent, we're breaking apart into an even and then one left over. So let's try the same thing with number 11. What's the square root of 81? 9. Okay, so we'll write 9. And then r to the 7th power is odd, so we need to break that apart into the square root of r to the 6th power. Good. And then times the square root of r. And then times the square root of s to the 4th power. We keep s to the 4th the same because it's already even. Now I'm going to just write the answer after this. I'm going to rearrange things slightly because the square root of r needs to go at the end of the problem. So we're going to write 9. And then r to what power now that it doesn't have the square root? Yeah, we divide the exponent by 2. Then we're going to write s after that to what power? S squared. And then times the square root of r. So 9r to the third s squared root r is the answer for number 11. Number 12 is very similar. I want you to give that one a try. Try number 12. And then we'll flip it over and answer the ones on the back. A little bit longer with the notes today, but not too much longer because once we get to the back, we'll have a decent idea about what's going on. Okay, so this 196, we actually saw that on our warm-up. What is the square root of 196? 14. Yeah, you can just use your calculator for that if you want to. And then we're going to multiply that by the square root of what? C to the 5th or something else? C to the 4th. Good, because 5 is not divisible by 2. All right, then that means we need one more square root of c after that because we're breaking it apart into 4 and 1. And then multiplied by the square root of what? What's on the end? We got the c. D squared, yeah. D squared is an even number, so that one's divisible by 2. Now we can square root the variables that are square rootable, and then leave this one because we can't square root that. So we end up with 14, and then what? C squared. Yep. Good. 14c squared d root c. All right. So these ones are like, I don't know, I feel like you can impress some people with this, but when it comes down to it, it's not super complicated. It looks like it's really, really, really complex and challenging. But once you kind of figure out what's actually happening, it's mostly the symbols that make it look really kind of terrifying. But when you break down and actually do the math, it's not so bad. All right, let's flip it over. We got a few more to get done on the back here. So let's take a look at number 13. So this is our first one where the number itself is not a perfect square. So 8 is not a perfect square. You are welcome to always use your calculator to work through these. What is the square root of 8? 2 root 2, yeah. So we're going to get 2 times the square root of 2. And then we can say times the square root of x to the power of 6. We don't need to break that one apart at all. Now, x to the power of 6, that one square roots to what? X to the third. So when we write our answer, anything that square roots is going to end up on the left side of the stuff that doesn't square root. So we're going to end up with 2x to the third power root 2. Everything that square roots, meaning everything that's a perfect square, ends up on the left side of the problem. Everything that is not a perfect square stays under the square root and goes on the right side. Number 4, the square root of 50, not a perfect square. What is the square root of 50?
5.
Yeah, 5 root 2. And you can just plug that into your calculator. It will tell you that. So we can say 5 times the square root of 2 times the square root of x squared. We're just breaking things apart. And then that'll end up as 5x root 2. Because the square root of x squared is just x. Root 2 stays under the square root. That's what we end up with. Any questions so far? This is almost, it's almost like another exponent rule, isn't it? It's like a bonus exponent rule at the very end of the unit. So you got to think of it as an exponent rule if you want to. So we have we have combining like terms, which you just add and subtract the coefficients. You don't mess around with the variables. We got our product rule where we multiply the regular numbers and we add the exponents with the same variables. We got our power rule. This is like the opposite of the power rule, basically. So instead of to the second power to the third power of our regular numbers, we are square rooting. And instead of multiplying the exponents together, we're dividing the exponents essentially by 2 because we're square rooting. So this is essentially the opposite of the power rule. How about number 15? What's our 2 root 17? Okay. Because that would be what? 17 times 4. Yeah, it makes sense. So 2 root 17. Now this one's going to be a little bit different because now p to the third power is not a perfect square. So we're going to have to write times the square root of p squared times the square root of p. So the ones that will be on the left side are the 2, obviously, because it's just 2. And then the square root of p squared is just p. So we're going to have 2p. And then when we write our answer, we can combine the square root of 17 and the square root of p under the same square root symbol. So we can say root 17p. And just put those together under the same square root. And your reminder here is you should never have more than one of the variables that are left. If this has anything bigger than an exponent of 1, that means there's another square root that could be square rooted from it. Number 16, the square root of 45n to the 11th power. How does that one break down? What is our 3 root 5? Yep. So because it would be 9 times 5, square root of 9 is 3, so you get 3 root 5. Is 11 divisible by 2? No, so we have to break that apart into what? 10 and 1. So times n to the 10th times n, or square root of those things. So 3 times the square root of 5 times the square root of n to the 10th times the square root of n. The square root of n to the 10th will turn into n to the 5th because we're dividing the exponent by 2. So 3n to the 5th, and then root 5n. Put the things that don't square root under the same square root symbol at the end of the problem. All right, I'm going to give you, I want you to try 17 and 18 on your own. Take a minute or two on those.
Is x and y like divides versus xy?
You're talking about number 17?
Yeah.
So x would have an exponent of 1. The y to the 16th, the 16 only applies to the y here, not the x. Okay. Does that answer your question? Cool. So working on number 17. I'm going to slide this down, and actually 17 and 18. I'm going to work on these two, and then I'll get the answers up in just a second. Mhm. Yeah.
And I'm like, yeah, all the time. And then 5 minutes later, he texts me, he's like, I got my homework at school.
I feel like anytime I go somewhere for a weekend or something like that, and I start driving away, I'm like, I know I forgot something.
Yeah, and then you get there. And you're like,
I'll figure it out. I'll figure it out later. Yeah, yeah. It's always something like that. All right, number 17. Let's have a quick look here. So the square root of 27 turns into 3 root 3. The square root of x, we're not going to be able to do anything with that because it's just x. The square root of y to the 16th, though, is an even exponent, so therefore that whole thing we can square root. So when we do that, the only other thing here that we can actually get out of from underneath the square root symbol, or the radical symbol, is the y to the 16th power, and that will turn into y to the 8th. And the square root of 3 and the square root of x need to remain underneath the radical symbol. Because we're dividing by 2. Yep. So that's the thing, is that we're not square rooting the exponent. We're only square rooting the number that can be square rooted. The exponent, when you square root a variable with exponents, you're not square rooting the value of the exponent, you're cutting the value of the exponent in half. So that goes back to the first page with the m divided by 2 portion here. So we're dividing that value of the exponent by 2. So we end up with, on this one here, 3y to the 8th root 3x, or 3y to the 8th times the square root of 3 to the x, or 3x. All right, for number 18, let's look at this one real quick. So our first step is right here. 180 turns into 6 root 5. X to the third power needs to be broken into x squared times x. So the square root of x squared times the square root of x. And then the square root of y to the 8th power, we don't need to mess around with that because the exponent 8 is an even number. It is divisible by 2. So our answer for this one, go ahead and take a look, see if you got this one right. It is 6x y to the 4th times the square root of 5x. Do we have any questions on 17 or 18? Because they're starting to grow a little bit if you haven't noticed. They're getting a little bit larger. But it's not going to increase the number of steps, though. The number of steps will remain the same. It'll just be more things in that first step. All right, let's look at number 9. So 160, square root of 160, a to the third, 19, sorry, 19. Square root of 160, a to the third, b to the 6th power. So the square root of 160, 4 root 10, good. So 4 root 10 times, what do we do with the a to the third? Okay, so we'd have a, times the square root of just a. Anything needs to happen b to the 6th? We need to break that one apart? No, 6 is divisible by 2. So the square root of b to the 6th, okay? So there's all that. The things that we can, and if you want to, make some notes about what you can square root and what you can't, you can use a highlighter if you want to and highlight the things that you can square root, like square root of a squared, square root of b to the 6th. Any way you want to just kind of prioritize that or highlight, or, if there are things visually that help you out, feel free to do those things. So I can square root a squared. I can square root the square root of b to the 6th. I need to keep the square root of 10 and the square root of a under the square roots because those are not square rootable. So we get 4a. What's that? It's not. I think I might be making up a word, but it's kind of fun. So we get 4a b to the third, and then times the square root of what? Yeah, that's it. 4ab to the third times the square root of 10a. Good. Sure, yeah.
6r to the 9, s to the 6th,
Square root of what? So 108 reduces to 6 root